Hello everyone. In today's lesson we are going to go over the basics of semiconductors. Before we start, here are the learning outcomes expected by the end of the lesson. As a learner, you should be able to describe 3 types of materials used in electronic components. Number 2, you should be able to classify semiconductors. 3, explain the concept of doping. And 4, explain 2 types of semiconductors formed through doping. Now, in electrical and electronics engineering, we have three main types of materials, which we are going to discuss for today, but we have 4. The fourth one is magnetic materials. So conductors refers to material that allow the flow of charge through them. An example of a conductor is a metal. Semiconductors refer to materials which allow the flow of charge to flow through them under certain conditions. For example, an example of a semiconductor will be silicon, that we know, and germanium. These are intrinsic semiconductors. We'll come to that later. Then we have insulators. Insulators do not allow the flow of charge through the material, for example, PVC. Now, semiconductors are broadly categorized into 2. We have intrinsic and extrinsic. Intrinsic semiconductors exist in nature in pure form. The key term is pure form. By pure form, we mean they exist as elements, while extrinsic semiconductors are formed by adding impurities to intrinsic semiconductors and thus exist as compounds. So for example, an example of an intrinsic semiconductor is silicon. If you take silicon and you combine it with, say, phosphorus, the compound that is formed by these 2 elements is an extrinsic semiconductor. Okay, then now the process of adding an impurity to an intrinsic semiconductor or a pure semiconductor is referred to as doping. Now when you dope a pure semiconductor, there are 2 types of semiconductors, of extrinsic semiconductors, that will result, which are N-type and P-type semiconductors. So under P-type semiconductor is formed by adding a trivalent impurity in a semiconductor. An example of a trivalent impurity will be boron. Let's use our pure semiconductor as as silicon. Now, assuming you have your silicon element here, then you have your boron, then you have your silicon. Let's just draw a small crystal. So because silicon has 4 free electrons, while boron has 3 free electrons or valence electrons. Now for this covalent bond to be formed, silicon gives 1 electron and boron, let me use another color, and boron gives 1 electron. Same case here, boron 1, this one 1, 1. In this case, this silicon element will give 1, but then boron will not be able to give 1 because it does not have an extra electron to give out. So what is formed is a hole. So here boron will form a hole, and since it forms a hole in semiconductor theory, this hole will mean that boron is an acceptor atom. So this means that this semiconductor is positively, we can say positively charged. In short, the free or the conducting whatever is conducting is a hole. Whatever is conducting is a hole. When you go to the n-type, it's found by the addition of pentavalent impurity in an intrinsic semiconductor crystal. For example, phosphorus. So we draw the same pattern. We have phosphorus, this is phosphorus, and then we have silicon. So phosphorus will give 5 valence electrons and silicon will give 4 valence electrons, such that when you form a covalent bond between the two, you'll have silicon will donate 1, phosphorus will donate 1, silicon will donate 1, phosphorus will donate 1, silicon 1, phosphorus 1, silicon 1, phosphorus 1. But then remember that phosphorus had 5, so already we have 1, 2, 3, 4. Now there is 1 which remains, so we'll have an electron which will be free. It will not have formed a bond, this electron, so we'll have an electron here. This is an electron. Since we have an extra electron, this type, the compound formed is called an n-type semiconductor, and phosphorus is a donor impurity atom, because it contributes, or it adds to the system a free electron. I hope I've been clear and you've understood up to that point. This is basically a very small introduction to semiconductor theory. We will deal with the rest of the theory in the next class. Thank you.